After I fail one time, so I'm not gonna deal with that.
Okay, I'm starting the recorder. So let's go ahead and get started. This is the first semester that I'm going to try a new format of my exam for this class.
No, that's not
So-
good. That's not good.
I think it's good. Okay, so I'll explain to you guys why it's good as soon as I can get started. Okay, looks like I can get started now. Okay. So we'll go ahead and take a look at the exam first. Okay, first of all, I have put calendar entries onto the calendar, the course calendar. On the 10th, which is next Thursday, we will have our exam 1. Okay, so you guys want to be ready for that. We'll only cover up to nested statements. Okay, up to and including nested statements, but excluding pre and post conditions. Okay, so I'm moving pre-post condition to the next exam instead of putting it into this one, because I think it's good to have more homework assignments first, so that you guys can get some hands-on experience, and I can give some feedback before we test on that particular subject. It's not like a good thing in a way that we can avoid it, right? We are not going to have it, anyway in our test. It's just not in the first exam. It will be in the second exam. Okay, so in a way it's bad because by the time we take the second exam, the pre-post condition thing will be kind of a long time, from the discussion itself. So it's not going to be fresh anymore, and that's why you will have to study even harder in a way, for the second exam when I move that topic to the second exam. Okay, all right. So having that, talk about that, let's move on and talk about the current exam. I put the practice exam into topic 3. Maybe no. Where did I put it? Topic 4. Okay, I put it into topic 4, into top-down design. That would be the wrong place to put it. Or did I? Where did I put it? Oh, right here. Sorry. Okay, I messed up. Let me increase the font size here, or decrease the font size. So it's actually in topic 2, at the bottom part of topic 2, is exam 1 practice questions. This is just it's not Excel, a calc spreadsheet file. And inside, are the questions, or the forms of the questions that I will ask in exam 1. Okay, it's not going to be the same number of questions. I think in the exam I will ask maybe 3 more questions or so. These are shorter questions compared to what I used to use, because what I used to do is to have a full trace. So it's going to be a lot of that is really repetition and chore, and that took up a lot of time. This one is a lot shorter. Each question is shorter, but it's kind of more to the point. I can actually assess whether a student understands the concepts or not. Yep.
And the exam is in here in our online, right?
Yes, it's in here, same time, same place. So it's going to be 80 minutes. It's going to be pencil and eraser kind of test. I'll give you the paper, so you don't have to bring paper unless you think you might need some extra sheets of paper. In that case, you might want to bring some extra blank pieces of paper, just so that you can work on something else, or if you think your answer is completely wrong, you can just cross it out and then work on a different piece of paper. So that would be good too. But I will leave space on the exam itself so that you can write your answer on the exam itself. Okay, so bring extra paper if you think you might need it. I don't think most people will need a calculator, because it's all going to be just basic arithmetics, addition, subtraction, multiplication, and that sort of thing. So I think a calculator may not be that helpful. No electronics. Okay, so no computers during the test. It's completely a paper-based test. It is open book and open notes. Okay, as long as it's paper-based and you prepare that prior to the test, you can bring it. Okay, in other words, if you can find like a lot of material related to this class, you can bring a big old binder of stuff. If you find textbooks from other places, other classes that you think might be helpful, you can bring that in as well. My personal choice will be studying the material that we studied, and come up with your own concise note just for the exam. So that way everything is in like 2 or 3 sheets of paper. It's easy to find it because you wrote it, and it's just more effective that way.
For the test, is it going to be all traces, or are you going to have us draw your
All kinds of
doodles?
questions.
It's going to be all traces. Okay, so in this practice test, I will give you a general idea of what kind of question you have to answer. So, any other questions about the exam? Yep.
Did you have a separate one posted earlier? Because I know I looked at one that said something about the exam, but it looked like there was pre and post conditions on it.
Yes. In prior semesters, I always include pre and post conditions in the first exam. So this is the first semester, that I also do not have pre and post conditions in the first exam.
Okay.
So you're correct about
So
that.
it's a different one.
It is a different one. This is a new one that I just prepared like last night. Yep. And part of the reason is also, it's really time consuming to grade the other ones that I had in the past. So this one is designed so that it would still do the job of assessing, whether, you guys understand the concepts or not, but at the same time, it's not overwhelming when it comes to grading. I used to have to spend like 6 hours, to grade one single exam for one class. So that's a little bit of time. Not to mention, it's not exactly exciting either. All right, so we'll go ahead and get started. Okay, this is really just a mock exam. Okay, so we can save the file, open it up in LibreOffice, and we'll get the questions. Okay. So here we have the questions, and let me trying to make it fit the screen a little bit better, because I think I opened up another document earlier when the screen was in a higher resolution. So that's why the window was kind of like a little bit beyond what I could see. Okay, so this is one question here. So there are 5 questions in the test, or in the mock exam. This is one question. I will give you the pseudocode, column A and column B from row 1 to row 6 is the pseudocode, and then I give you a starting point. So I don't need you guys to start from line 1. So that's one thing that you have to remember, is I'm starting with line 2 in this case. Line 2 is all done. Because when you look at line 2, okay, let me just highlight the portion that I'm talking about. When you look at line 2 in the trace, it means at the end of line 2, n ends up with a value of 1. That's basically what it means. Okay, it's the same convention that we use in tracing, in the tracing homework assignments. Okay, a value that is on the row of a particular trace means that's the ending value of a particular variable, not the starting value of a variable. Okay, so by the time I'm done with line 2, which is an assignment statement, n already ends up with a value of 1. So now I want to continue the trace. Which line should I go next? Okay, we have to go out of the conditional statement. We go to line 4, and on line 4, I don't update anything. Instead, I have to evaluate the condition, which is n is less than 8. Is that true or false? That is true. And then where do we go?
5.
We go to line 5. Line 5 is going to do what? N gets n plus 1. N is 1 at this point. So 1 plus 1 is 2. Okay, and then we go back to line 4. We reevaluate the condition, and then we go back to line 5. And this time, what happens to n? It becomes 4. Okay, and that's the end of the trace that we need to do in this case, because according to the instruction, trace the code until the algorithm exits or n is updated 2 more times. Okay, so that will be row 4 and also row 6 in the trace. Now that we have done 2 additional updates, we're done with the exam question. The algorithm is not done, but as far as the question itself, that's all I expect from a question like this. Yep.
So just do a dead stop and no post? Nothing?
No post, because we are not done yet. The algorithm is actually not done, but this is all that I need in order to grade this particular question, to see whether you know how to get out of a conditional statement, that the conditional statement is not a while statement, it's not a loop, and also a loop is a loop, and how to get back to reevaluate the condition. So all the critical stuff is already here. It's just that I don't need you to finish or do the repetition so that I can see that you can finish the whole thing.
I was trying to figure out why it didn't reiterate for 2 twice.
Because line one.
So then it goes to the while. It doesn't.
Because it's a conditional statement. Remember what a conditional statement looks like. Okay, it's a branch like that. You have something to do for the then case. In this case, because I don't have an else, that means the alternative path is just just a straight path here.
Yeah.
So when you're done with this, you get out. There's no way to loop back. Okay, so this is why you need to kind of look at all the statements again. Make sure you understand how to draw the picture. Now, you don't necessarily have to draw the picture. In fact, drawing the picture, as a part of your answer is not going to get you any points by itself. Okay, but it might help you, understand or clarify the concept enough to answer the question correctly, and that will get you points. Okay. I don't want anything to be missing in this case. In other words, what I have shown here is the minimum that you have to turn in. Okay, that means you have to trace line 4, line 5, line 4, and line 5. You have to indicate the conditions, whether it evaluates to true or not. You also have to show me the updates of variable n in this case. Yep.
So would it just, if you didn't only have to go to that point if you finished it, would it just go 4, 5, 4 post?
It would go 4, 5. Okay, it would basically, now we're on line 5. It will go back to line 4, and then it will go back to line 5 one more time, so that n will become 8, and then go back to line 4. Then 8 is not less than 8 anymore, and then it would go to post. Correct. Yep. All right. So are there any questions about this question? Okay, so that's one. The second question is about the same, but you do have to read the instructions because the instructions may or may not be exactly the same. So in this case, in the second question, the instruction is start with finishing the trace of line 11. In other words, line 11 is not done yet, okay? Then trace the algorithm until the algorithm exits or m is updated 3 more times in this case, whichever occurs earlier. Okay, so if it exits before it updates 3 more times, fine. Okay, just exit and say post. If it requires more iterations, then you have to perform the additional iterations. Yep.
So when your instructions say the tracing of line 11, you're talking about line 11 of the sheet, not of the algorithm, correct?
Line 11 of the algorithm.
Which is going to be updated?
Because I'm missing one little thing on line 11. Line 11 needs to do one more thing.
You don't have
Oh,
one
I don't have a line 11. That's right. Okay, I think that's meant to be 1. Yep. I have a bouncing keyboard problem. Like that. Okay, so it's line 1 and not line 11. Thank you. All right. But line 1 is not done yet because it is the first line of a loop. That means we have to evaluate the condition. So this is what needs to be done in this case. We have to say n is less than m is true, okay? And then we go to line 2, and line 2 says n is greater than 8 is it true or is it false?
False.
It is false because it is exactly the same, so it is false. So then we have to go to line 5. Line 5 is going to subtract 1 from m. M goes from 20 to 19. And then where do we go? 7. Yep, exactly. Don't miss line 7 because it is right after the conditional statement in the loop. So line 7 is going to subtract 1 more from m. So m goes from 19 to 18. And then where do we go? We go back to line 1. Line 1 has to reevaluate the condition. N is less than m is still true because 8 is still less than 18. Then we go back to line 2, which is n is greater than 8. It is false. Well, we haven't done anything to n, so it is still false, right? Then we go to line 5 again. Line 5 is going to subtract 1 from m. So m goes from 18 to 17. And that's it. Because the instruction said, until m is updated 3 more times. So we have once, twice, and 3 more times. The trace is not completely done, but as far as the answer of this question is concerned, we are done. Are we doing okay so far? Okay? So I'm still testing all the important stuff. Okay? In this particular case, I'm testing, do people understand that the conditional statement from line 2 to line 6 is actually at the same level as the assignment statement on line 7. So that when you're done with the conditional statement, you still have to move on to line 7 and perform that. And also line 7 is something that you have to do regardless of whether n is greater than 8 or not, because that really only determines what you want to do in the conditional statement. But m gets m plus 1 on line 7 is outside of the conditional statement. Okay? Any questions about this particular one? So as you can see, it doesn't take much time, and that's why I can afford to ask more questions, because each one does not take as much time. And that's a good thing too, because if someone messed up on one particular question, it's not going to make a big hit on the overall grade as long as the other ones are okay. Whereas before, I only asked 4 questions. Okay, if on any one of the questions is messed up, it's going to take a big hit as a whole. In this case, it's not going to be as big of a hit because I'll be asking probably 8 questions or so. I'll double the number of questions just to make sure that people have a second chance or third chance to get something right. Okay, that only helps if it's a stupid mistake or a mistake due to just overseeing something. It doesn't help when it's a conceptual mistake. If it's a conceptual mistake, that mistake will basically be present in all of the other questions. Okay, this is the third question. The third question is also in the previous test, and you want to read the instruction first, like that. Find a value of x so that z ends up with a value of 3. If it is impossible, explain why. If it is possible, trace the algorithm from pre to post, starting with specifying the value of x in the precondition line. Okay, so you want to look at the code first. Okay, so here we have the actual algorithm, and you ask yourself, how can z possibly end up with a value of 3 given this is the code that we have?
Line 7.
Line 7. Well, line 8. Okay, line 8 is the assignment statement that will make z equal to 3. Okay, so now the question is, but first of all, are there any other ways so that z ends up with a value of 3? No, there are no other ways. So line 7 or line 8 is the only way. So now the question is, how do we get to line 8? How do we get to execute line 8? Like that. X has to be greater than 3, okay? But there are other things too. It cannot be 4 either, right? Okay, so we'll take a look at this one here, and we'll say, okay, we want this to fail. We want x equal to 0 to fail. It cannot be 0, okay? In other words, you can kind of start to rule out things first, okay? X cannot be 0. X cannot be 4, because if x is 4, then we'll execute this branch here. So it cannot be 0, it cannot be 4, it can also not be less than 4, right? So now we have just ruled out everything up to and including 4 itself. Okay, so we're starting with 4.1. I didn't say you have to use integers, so you can use 4.1 if you want to. So if x is 4.1, would it meet this condition? Would it make this condition true, but all the other ones false? The answer is yes. Okay, well, that means we got the answer here. So we can just specify 4.1 over here, and the column is a little bit too narrow. Here we go. And then we can continue with the actual trace, starting with line 1. So this one, you do have to start with line 1 and then finish the entire thing. So on line 1, x equals to 0 is false, and then we skip to line 3. X equals 4 is false. Then we go to line 5. X is less than 4 is false. Then we go to line 7. X is greater than 3 is true. And then we go to line 8. We update z with a value of 3 as a result. And once we take one branch and the branch is finished, we exit the entire multi-branch conditional statement. We get to post, and we're done. Okay. Is there any value here that is impossible to get to?
5?
Yep, 5 would not be possible, because you need all of the conditions to be false in order to get to line 10, which will turn z into 5. But that's impossible because you cannot find anything that is not less than 4 and not greater than 3. That would not be possible. Okay. Now, but you also have to remember the impossible case doesn't have to be the last one. Okay, I can make the impossible case the first one. I can make line 2 impossible right off the bat. All I have to do is to say on line 1 of the code here, I can say if false, then z gets 4. Right off the bat, it's not possible because false can never become true. Well, does that make all the other branches impossible too? No, because if the first condition is false, you go to the next one and then the next one. So any of the branches can be a dead branch if there's a dead branch. Okay, there's no limitation of, oh, it has to be the last one. Nope, any one of them can be a dead branch depending on how the logic works.
So for that line, that comment would just be false is false?
Sorry?
If you said like at line 1, you said you'll write, if false then, right?
Uh-huh.
So what will comment be? Just false is false?
The comment
Yeah.
in,
For that line?
oh, you mean when you trace?
Yeah.
Yes, then you just say false is false. Because the first false refers to the condition of the conditional statement. The second false refers to the value of the expression. Now, it turns out in this case, it's a constant, so it is its own value. Okay, but you still have to state, false is false, and that is why we are not going to take the branch on line 2. Now, you might want to ask, why would anyone write a conditional statement and intentionally state this is false? Okay, because it doesn't seem to make any sense whatsoever, right? Why would you write a program like that? It's one, sorry?
You can still do it
You can still do it.
in programming reality.
You can still do it. It is
Yeah.
perfectly okay in terms of the syntax and also semantics. Okay.
Right.
Sometimes people do that because when they're debugging a program, there are sections of code that they might want to what we call comment out. Okay. In other words, they want to disable a part of the code in order to test the program. Okay. And when you want to make one section of code non-functional and not do anything, one quick and easy way to do it is to put a conditional statement around the whole thing and make the condition itself false. So that means the entire block of code would just bypass the entire thing. But you're not deleting that piece of code either because it's still there. And to re-enable it, you just have to turn false back into true. Then the entire block of code is live again. Okay, so that's kind of like a debugging technique. If you want to debug and disable a part of your program for debugging purposes, that's one way to do it. And you will learn all the other tricks of how to disable sections of code later on, and some techniques are better than others. This one I find to be quite useful. Okay, so here's the last one. Yep, go ahead.
One quick question about that previous one.
Mhm.
You wrote down 4.1 on there. I didn't quite understand why you did that.
4.1? I
Yeah.
could just 5
Be
or
greater than 4.
yeah. I didn't say it has to be an integer.
Oh.
Okay, that's fine. All right, so here's the last question. The last question is, once again, the trace. The instruction says continue the trace until the algorithm exits. Or you can conclude the algorithm can never exit. In other words, if you think, there's an infinite loop here, it will never finish, then you can also stop as soon as you realize it's an infinite loop. If the algorithm does not exit, in other words, it's an infinite loop, explain why. Why do you think it will never exit? Okay, so that's basically what the question is asking. So the first thing we want to do is to figure out, well, is it really going to be an infinite loop? An indicator that is, yep, go ahead. Okay, wrong sheet. Thank you. Thank you for the reminder. There you go. All right. So is the algorithm infinite? Okay, let's
Kinda
go ahead.
Looks like it.
Hmm?
It is.
Kind of looks like it. Yeah.
Well,
Not positive though.
you have a loop where I is greater than 3, then you can well, yeah. You have a loop where actually no, that's just a conditional statement.
That's right.
No,
I
yeah.
throw that up there. Yeah, I is greater than 3
Yeah, no.
because I want to see if
like
people look at that and go like, it's not possible to get out because I is only going to increase, and that will always be true. I is greater than 3, and therefore we cannot exit. But hold on a second here.
It will.
That is not a part of the condition of the loop. It is a condition of the conditional statement containing the loop, right? It's a one-shot deal. So let's go ahead and actually trace it and figure out what it's going to do. Yep.
On line 3, I don't know
Yeah,
It's not
it is
equal.
less than greater than, which means not equal to.
So it's not the fun.
Because it gets stuck there.
Well, let's see what it's going to do, okay? Because when we're tracing, the nice thing is, we can actually try to figure it out, right? Okay, so line 6 is already done. Line 6 is this line here, and it says, after line 6 executed the last time, I ended up with a value of 4. Don't ask me why, okay? It's just because, okay? Now, I can actually answer the question why. It's because before this line, I had a value of 3, right? And why does it have a value of 3 before that line? Well, that's because, after the conditional statement, it ends up with a value of 3. But why is that? Well, let's see, okay? Because we have 2 ways to go back, in that direction. If I does not equal to 5, then I gets I plus 1. So that's because I had a value of 2 before line 3. And why is that? It's because I has a value of 2, which is less than 6 prior to that. And why is that? It's because, well, that's interesting because that really should not be possible to get into here, right? But assuming that is the case, we'll go ahead and with the trace, and then I will explain why it is not possible. Okay, I picked a really bad value to trace at this point. Some of you already know what I'm talking about. That's a good sign. If you don't know what I'm talking about, it's okay. Well, I'll explain it later. How many people can see the flaw of this particular trace?
Can we just make it false?
No, it's not. It's not false. Okay, because if I tell you that on line 6, I has a value of 4, you have to use that assumption and continue with the trace. But I'm just telling you that there's no way I can have a value of 4 at that point.
Conditional statement wouldn't let you go in.
No. It's yes. That eventually is the reason. But why is it the case? Because I has a value of 4 right now, so 4 is greater than 3. We should be able to get in here.
You go backwards, it's -1, -1.
Exactly. That's exactly why. That's very good analysis. But assuming that really is what the question is asking, I can always kind of fix that. Now it's possible, right? Okay, so we'll get back to that one a little bit later because that is basically pre and post condition debugging, right? All right. So we'll go ahead and continue with line 6. After line 6, where do we go?
2.
After line 6, we go back to line 2 because line 6 is the last line of the body of the pre-checking loop. On line 2, we have to indicate I is less than 6 is true or false. It is still true because 4 is less than 6. Then we go to line 3, we evaluate I is different from 5, and that is true because 4 is not 5. And then we continue on to line 6.
4.
Oh, it is true, but so we have to go to line 4. That's right. And oops, line 4 is here. We bump up the value of 4 to 5 in I, and we continue execution on line 6. So 5 will go to 6. The value of I will go from 5 to 6. Then we go back to line 2. The condition of I is less than 6 is false now. And then we get to post right there. We do not get back onto line 1, okay? There's no going back to line 1 because line 1 is the beginning of a conditional statement. Remember the picture that I drew? Yep.
Is that because it's an if and not a while?
Say again?
Is that because it says if and not while?
That is correct.
If it was while, it would just keep going.
Yep, if it were a while, if I said, on line 1, instead of if, I say while I is greater than 0, then do, and then on line 8, I say and while, this would have been an infinite loop. Because it just won't exit. But as an infinite loop, it also has an interesting property because it will not get into the inner loop anymore. Because as long as I is greater than or equal to 6, it's not getting into the second loop. So it will just go 1, 2, 1, 2, 1, 2 indefinitely. Is that okay? So these are all the things you can kind of play out. Okay. So in other words, if you want additional practice, what you can do is you can take this code, stash it down here, and then you say, okay, what if I change this code here? What if I change this to while do and change the end if to and while? Okay. Now you already know, because I said that already, that this will turn it into an infinite loop. But as an infinite loop, what is the pattern? Because as an infinite loop, it usually has a pattern. Okay, you're repeating certain line numbers over and over again. So when it's getting into the quote-unquote infinite mode, which means you can definitely see that nothing is being done and the conditions are staying the same, true in this case, it just goes to line 1, the condition is true, it will go to line 2, the condition is false, then we'll go back to line 1 right away. So it will just alternate between line 1 and line 2 when you trace it. So these are the things you can do to kind of get additional questions out of the questions that are already asked here. Yep.
What if we got rid of line 6?
What if we get rid of line 6? That would be interesting, because if you get rid of line 6, it will still work.
Still loop, but it won't grow?
It will still grow as long as I does not equal to 5. So it will grow up to 5, and then it will stop.
And
then
will
it
we
becomes an
exit
infinite loop. Then it will become an infinite loop. The inner loop itself becomes infinite.
But it didn't grow.
It does not grow because there's no way to make it grow, because when I becomes 5,
It doesn't go in there.
then it doesn't go anywhere.
What are we talking about if you have an infinite loop and the value stays the same through a certain amount of loops, that the computer will kind of summarize that as?
The computer does not know, because when you write programs, like in this case, the computer would keep going over line 1 and line 2, but it doesn't realize that it is an erroneous condition.
It'll just keep doing it.
It will keep doing it. It becomes what we call an infinite loop, so your program will never exit until you kill the program.
I thought computers had like
He's
they
talking
could
about when you-
recognize an infinite loop at a certain point, and they'll just cut it off.
No, they don't.
He's talking about when you run out of RAM.
It
When
just
you-
doesn't
When you talk
crash.
about how the computer will run out
Doesn't even
of
crash.
space.
Yeah, it doesn't even
Doesn't
crash in this
Right.
case.
Bad enough it
But this
crashes.
does not use up any additional RAM.
Right, because
okay?
you're not adding anything to.
I'm not
Right.
creating anything.
Right.
I'm not updating anything either. I'm just checking the conditions over and over again. So in this case, it will never exit, and that's why in really critical systems, like systems on satellites or space probes, things that we cannot retrieve or cannot afford to be stuck in an infinite loop. Okay, all of those things have a device called a watchdog timer. Okay, a watchdog timer is named. It's basically the same thing as a. It's not a dead man switch. It is a. Well, I don't know how. No, it's just a watchdog timer. A watchdog timer is a hardware device that is independent to the main processor itself. Okay, and what it does is the main processor running a program that is supposed to be healthy will have to, we call it hitting the watchdog, which is basically resetting a timer. Okay, so think of it like this. Okay, you have a kitchen timer thing. Okay, so you dial it to say 15 minutes. Okay, so you walk away, you do certain things. All right, but before 15 minutes is up, you need to come back and reset that timer back to 15 minutes. Okay, so the program, a legitimate program that is healthy, would actually be programmed to do that. Now, what if I just want to do something for 5 seconds and then come back in and reset it 15 minutes? That's okay, no problem. Okay, you can reset it every second, you can reset it every 10 minutes, you can reset it every 14 minutes and 59 seconds. They're all considered okay. But what if you go outside to your yard and a branch of the tree fell off and hit you, and you are not able to go back to the kitchen to reset that timer?
That's where the watchdog.
The watchdog timer will go off. Okay, so in this case, it's a timer that will probably be attached to a phone surface, and it will call up the ambulance to pick you up from the backyard because something bad just happened to you, right? Are you guys getting the idea? That's a watchdog timer. So in critical systems, even on most PC these days, they have the same device. It's called a watchdog timer, which means the operating system under normal healthy situations will hit the timer, every so often. Okay, I don't know the exact period of time. It could be 10 seconds, it could be 5 seconds. I have no idea. But when the operating system, for whatever reason, is stuck, okay, it could be a hardware issue, it could be a software issue. We don't know. Okay, but for whatever reason, it's stuck and cannot hit the timer anymore. then the watchdog timer will go off, and in this case, it will just do a hard reboot of your system or just turn it off. Okay, it's basically saying, okay, something is really terribly wrong here. I'm going to shut off the computer. I have had one. Go ahead.
And so in satellites, do they call them, or does it just reset the?
Most of the
reset
time,
program?
because you cannot have someone to surface, the satellite right away. So what usually what it does is it will just reset the system, because it can be a little hardware issue. In a satellite's case, can be because of radiation from the sun and whatnot, which is not a very repeatable event. So when you restart the system, hopefully, it will just fix it for another 5 years or so.
Okay, does it just kind of keep resetting?
No, the software has to reset the timer. You have to basically dial it back to 15
But I mean,
minutes.
if there's a problem and it keeps on.
If there is a recurring problem, so every time the timer does go off, ideally speaking, someone on Earth, should get a, log message of some kind to basically say, okay, something bad happened, that software just restarted due to a watchdog timer reset. So that way, the next time, someone has a chance to go up there, or if they can remotely monitor the system, they can look into the problem and say, okay, can we fix that? Okay. Any other questions? No other questions? So this is basically the format of the test, okay? It will be fairly short traces, and there will be like maybe 8 questions, like that, like this. Any other questions?
Will those be the only kind of questions?
Sorry? Say again?
Will those be the only one kind of questions?
Yeah, these two, okay, there are actually 2 types of questions. One would be a trace like this one, and the other one is this one here, which is actually a little bit analytical, because I give you the code, but I'm asking you what value of X can cause a particular thing to happen. So that's kind of more analytical, because I'm not giving you the initial value and you just trace it. I'm asking you, how can we get to a certain point, or can we get to a certain point? So that's more analytical, but yet it is not strictly pre and post condition kind of thing.
So like on the last one that you did, where you went back, where you had to go back and like a few steps to see if you can even process that code. Do we have to change the number? Like, is it going to be like on the test too?
No, even on the test, if I gave you the wrong version, when like this one here, and I initially had the condition stated incorrectly, it would not have affected your trace. Because if I told you that somehow I got started on line 6 already, then you just continue from line 6. Okay. Now there is a possible way for this to get to line 6, even with the incorrect code that I had a little bit earlier. So let me just kind of flip it back to the original code, which is I is greater than 3 here. It is still possible for me to end up on line 6 because of a taboo statement in all programming languages. So if I change the program just a little bit here and say, oh, by the way, this thing here has a label 1 defined here, okay? Then it becomes possible, because I can jump into this label from anywhere else in the program and skip line 1, the conditional statement, and skip line 2, the condition of the loop itself, and go straight into the body of a loop. Okay. In other words, this becomes possible if I just have a label here, because with a label and a go-to statement, I can get back to this point from any place. And that completely messes up, any type of analysis you can do to the program. And that is also why, the go-to, G-O-T-O statement is also known as the G word in programming, because we do not dare to say that word. You will see, from other programming classes, why go-to is not a good idea. The problem of go-to is not just that it is a bad idea, but also because sometimes it's a handy thing to do. It's like, oh, I can fix this program if I just make a go-to statement from here to here. So it's very tempting from time to time to say, oh, I can just use a go-to. If my instructor let me use a go-to, then I can just fix this problem in 2 minutes. Yep.
How did the robot thing go yesterday?
The robot thing.
Did you say there was?
Oh yeah. We actually got the robots to run around a little bit. We figure out how to read the sensors and control the motors. So what Danny, who's the president of ARC Dev Club, ARC Dev for developer, instead of calling it CIS or CS, they decided to name it after developer. So we managed to get the software to talk to the hardware, control the motor, read the sensors and whatnot. So I think they will organize a competition really soon, like in the near future. What we'll do is we'll do a straight line competition first. So what we'll do is we'll tape, this carpet is actually reflective in the IR spectrum. So what we'll do is we'll use a black tape and tape a straight line, and we'll have the competition entries to basically follow that line from the starting point to the ending point and see which one can do it the quickest. Now you might think, well, that's easy, just turn on the motor and let it rip, right? No, because if it is long enough, something will cause the robot to steer off course, even though the line itself is straight, because the traction of your tire is not perfect. The carpet itself is not perfect. Gearing itself is not perfect, right? And the connections, okay, the cables, the wires on the robot, they are not perfect either. So at some point it will veer off, enough that it won't stay on the tape anymore. Okay, so you still need to read the sensors and figure out, okay, how do I make adjustments and still make the robot go as fast as possible from point A to point B. Okay, so that probably will be the first competition. The program is, the robots are programmable in C++. So for those of you who are, already learning C++ on your own or from another, place, you can probably enter that competition. Okay, it sounds really easy, right? You just go in a straight line as quickly as possible. So the next competition is going to be around a curve, okay, or possibly a loop. Okay, so you have to basically go like 5 laps and see how quickly you can go through the 5 laps.
Get your robot to go in the straight line.
Mm-hmm.
Can it just do the curved also? Because wouldn't it, if you
it depends on how badly the curves are, structured. Because in some competitions, you can have curves that looks like this.
I mean, the program tells it to trace the line. It'll trace it.
Yeah, but how do you do it as quickly as possible? I mean, you can kind of wiggle and snake your way through, but it's not going to be fast.
Yeah.
So that's why it's a challenge. It's actually a very interesting control problem in engineering. When you have to go through courses like that and can only rely on fairly simple software. Okay, so it's interesting. Okay, it's not as simple as most people think it is.
Technically, you can't give it like a constant speed or X speed, because at a 90-degree turn it may topple over. If you just give it a constant speed, it has to be able to give feedback as to.
Yep, you have to read the
X
feedback.
degrees left, then I know I'm going to turn or fall over if I'm going X speed.
Yep. And then those robots are called Sumo, Z-U-M-O, robots, and that's because they're named after sumo, like Japanese wrestlers. So these robots ultimately are designed to push push each other out of a ring. Okay. But since it seems like you guys are more interested in this stuff than the programming stuff, so we'll go to YouTube and just look up that sort of thing a little bit. Okay. So sumo bot wrestling. Okay, so I'll show you the the really easy ones. Okay, these are the Japanese ones. Those robots are crazy.
They have such good robotics. I was watching an exoskeleton program yesterday.
Mm-hmm. Note that they're both wearing gloves, thick ones.
Just in case it takes off.
Oh, just watch, you will understand why. They're trying to seal the robot as much as possible on the surface so they can scoop each other. In slow-mo. Woo! Okay, so if you want to
So
see
he's
some,
actually getting it to read the edge of the ring in order for it to stop and back up and turn
yes.
around?
So it's basic. It's kind of like it's modeled after actual sumo wrestling.
Sure.
Okay, where you know two big guys try to push each
You just
other
try
out
to
of the
accelerate
ring.
as fast as you can.
Yeah. Well, you can also do tricks like you can actually kind of toss the other guy. So these things, they're not really just brute force. Some of these things are actually intelligent as well. If you can sense where the other robot is and you can sense it's approaching you, what you can do is you can make you can basically say, okay, keeping in this, coming in this direction, and then what you do is you turn around at the last minute, let the other robot pass, and then push it a little bit back, right?
And are that's automated, so as soon as
These
you
are
hit their button,
these are
it just
fully
does its own-
autonomous robots, so there's I mean you cannot possibly
Yeah, there's no
control
way
it
you can
that
direct
fast.
it at that
There's
fast.
no way you can control it, at that kind of speed. I mean these things are just crazy, fast. Now there are also sumo bots that can run upside down. So let me see if I can find that for upside down. Okay. Okay, the Japanese versions of these, sometimes because the limitation is weight, okay, how much the robot weighs, like dry weight, okay, and they have different classes. They have mini sumo bots, which is one particular class, and then they have the medium class and the big ones, that are like much bigger. So in order to increase traction, obviously traction is something that you want, right? Because you need traction to push the other robot. So in order to increase traction, but not increasing the overall weight of the system, they have like suction. They run like a suction cup thing to try to suck onto the surface as much as possible, and then the suction is enough that these bots can run upside down on a flat surface. They can run upside down. Now, I wouldn't be standing anywhere close if they're running upside down, but
I was just about to ask, because I know in F1 they had something very similar. They used turbines to suck air from the venturi tunnels and vent it out the back. And those were some of the fastest cars for a long time because they actually corner faster than you think.
Yep, and also the airfoil itself is also designed to push down on the Formula
There's
One.
enough downforce that they can actually
Right.
go up and down.
But,
Yep. But these are stationary. They can be like not moving at all and still have the suction to suck it down.
With the F1 they had it directly attached to the crankshaft.
Oh, okay.
So that you could just, some of the cars when they revved up, you could actually see them hunker down because they're being sucked down.
Oh, interesting. I did
Yeah.
not know that.
And they actually outlawed, or they made it illegal in F1 after a couple of races because they were just.
Because they just
everybody
basically
does.
glue onto the asphalt, right?
But when it runs out, it's explosive. So like, if you're going around a corner and you let off too much, that section will go and it'll just fly.
Because your engine speed is lowered, and as a result, your traction is gone as well. That is funny. Okay. Well, I think I have talked about a lot of applications of computers and electronics in different kind of things, right? We talked about what? We talked about snap-on torque wrenches, right? Okay, so I'm going to talk about something that might make some people uncomfortable. I'm hoping that it really is not the case. It's about guns, okay? But in this case, it's about air guns, okay? We're talking about air guns that are legal in Great Britain, without a special license. So they're basically 12 foot-pound or less in terms of energy. So they're definitely not toys. They can definitely hurt people, but killing people, probably not. Okay, unless it's a really, really well-placed shot at some really weird place. Probably not. Okay, so it's not it's not like firearm. It's not designed to hurt people. It's designed to hurt mice, rats, and that sort of thing. Cockroaches. So anyway, but what does computers have anything to do with air guns? We are not talking about those guns that the military use. I mean, obviously in that case they want precision, they want efficiency, they want all kinds of other things. But we're talking about air guns that people use to hunt rats. Okay. What do you think computers have anything to do with it?
Help with velocity.
Hmm?
The design.
The design. Okay, now these are air guns, right? So these are air guns that are also called pre-charged pneumatic air guns, or PCPs. And the way they work is they have an air tank, and you charge it up to about 3,000 psi, and then it has a a valve, okay, and a hammer. Usually it has a hammer. So the hammer is spring loaded, and when it is let off, the hammer will hit the air valve. The air valve will let up, will let out of a certain amount of compressed air, and then the compressed air will basically just blow the pellet out, and that's how it shoots pellets. Okay, and that's why it's an air gun, because it just relies on compressed air. So why do you think computers will come into this scenario?
I'm just wondering, is that different from like the air guns that they use on like sharks and stuff?
On sharks, like the harpoons and stuff
Yeah.
like that? Yeah, those are also compressed air operated. But in this case, because
It's actually shooting something.
it's actually shooting something out.
Like a
Yep.
CO2 beam gun.
Yeah. Well,
Kind
kind
of.
of like that, but it's just using compressed air instead of CO2. But I think I can think of scenarios where the technology can also apply to CO2, also. Okay, so the thing has to do with as you shoot shots after shots, the air pressure within the tank can change. Okay, it will decrease over time. So that means when you let out of a blob of air, that blob of air will contain less and less energy unless you do something about it, right? Okay, so nowadays they make air guns that can electronically monitor the air tank temperature and also pressure. And then depending on that temperature and pressure, it will control the on time of the valve. So it will basically control the duration
Make it go longer.
in milliseconds, how long to open up the valve, so that the pellet will still come out at exactly the same velocity time after time after time. Okay, and if people have money, they can buy the even more upgraded version that actually has a internal chronograph. In other words, it actually measures the time of the pellet going through the barrel from point A to point B. Okay, and it will compensate the opening time of the valve to make the pellet to come out at exactly the same speed. What speed are we talking about? About 800 feet per second. For those of you who own, or operate firearm, that is a very, very slow speed.
Yeah.
I mean, again, these things are designed to hunt rats, not any bigger of animals. Why do you need that type of consistency and spend like upwards of $2,000 on an air gun?
Wow. That's awesome.
Okay, how big is? Yeah, go ahead.
I was just thinking, kind of like with an air conditioning system where like it's not very accurate, so it like, let's say you try to keep it at 70, and the air conditioner turns on, it'll
Right.
take it all the way down to 65, and then slowly work its way back up.
Yep.
If you have an air gun and it's doing that, you can have it where it's like, let's say you use it as like a fly, as like to kill flies. You
Mhm.
only kill like half the flies because
Yep.
it would just over time.
It's not effective. Air gun people are a little bit different from firearm people in certain ways. I have read about people. Okay, in air guns they have these they call it FT, field target, competitions. The field target competitions, they would hunt, chickens, cows, pigs, and I think some other animals too. But they're all silhouettes. In other words, someone cut out, from 1/4-inch steel plates, these little silhouette of animals. So you have chickens about this big, and other types of farm animals about yay big, and they would put these things all over the place. And then these air gunners would have to go in and actually, quote unquote, hunt down the silhouettes, and knock them down basically with a pellet. And it's a really common competition. It's a good marksmanship competition, but you're not spending a lot of money. You're not hurting anything except for the poor steel silhouette chicken. So yeah, it's a different kind of crowd doing that sort of thing. And I know people also they hunt flies, so they would put a tray with like rotten fish and other things, at about 20 yards away. And then they would shoot the individual flies, hovering over the fish.
That's pretty cool though. I mean, that takes a lot of accuracy to be able to
Steady hands.
get that.
Yeah, and that's why the Olympic Games also has a 10-meter rifle and 10-meter pistol, air pistol and air rifle competition. Yeah, if you try that, you know how hard it is. It's insanely, difficult to, to get any points for a normal person to
It's
get
hard
any
enough
points
just
at
to
all.
do the skiing part, let alone the.
Yeah, they have the ski and a ski and shoot one. Yeah. So, but that really tells you, how the technology has evolved, over time. I sent every single one of you a spam piece, this morning, comparing two technologies that came out of World War II. Okay, one technology was the jet engine or jet-powered airplanes. Okay, the Germans, first, got it, but they never really got enough time to manufacture and deploy them. Okay, but it did came out of World War II. The second one was electronic computers. Okay, if you go to any type of show, that will show technologies from World War II, which one do you think will look more attractive? The German jet airplane versus the first ever electronic computers with all kinds of vacuum tubes and whatnot.
Jet engine.
Obviously, right? And then you fast forward time to present time, 2013, okay? Well, jet engines have changed over time as well. But if you look at a modern, jet engine and you compare that to the elementary, jet engine from World War II, they are different, but at the same time they're about the same. Okay, the same concept. The size is about the same. More efficient these days. We might be talking about what in terms of efficiency, maybe 4 times as efficient. I'll give it 8 times, 10 times, maybe 20 times. Okay, I don't think you can push it any more than 20 times. Okay, because it ultimately depends on the fuel, right? I mean, it's just burning fuel, and the exhaust is the thrust. When you look at computers, well, how much speed up are we talking about? Remember Moore's law?
Every 18 months.
Every 18 months, doubling. So how many doublings do we have since the end of World War II to today? So let's say there are 60 years in between, right? 60 years means there are 20 3-year periods. And each 3-year period has 2 18-month periods. So we are talking about 60 periods. In other words, if Moore's law, was true back then, and it kept itself up all the way up to the present point, computers are now 2 to the power of 40 times the efficiency of the ones coming from World War II. I don't think jet engines saw that kind of advancement at all. And not only that, okay, we are not only talking about the efficiency in terms of how fast the computers are. What about the size?
Filling the room and filling your pocket.
Yeah. Well, you're packing a lot more processing power than they could fit in a room, in a building, back in World War II. So what does that have anything to do with this class? Computers are now the enabling technology for other things to happen. And that means if you double major, your chances of getting a stable employment and doing something that is fun is much better than just doing computer science as a major itself. You have to combine computer science with something else. You apply computer science to something else. It could be robotics, which is mechanical engineering, and stuff like that. It can even be civil engineering. Okay, people think of civil engineering as a really boring field, right? I mean, you're designing bridges right? I mean, how exciting can that be?
Yeah, but the modeling that you can do, especially with computers and everything else, I mean, is phenomenal.
Yep. These days you can do modeling, but you can also do all kinds of sensing now. So they have these sensors built into bridges that can send back information. Whether it's vibrating, stress, and anything like that, it can come back with with a report. So let's say a bridge, for whatever reason, okay, maybe a truck exploded on the bridge. Okay, maybe it's just an accident. Okay, so how do you know whether the bridge is still safe to operate or whether you have to shut down the entire bridge because of that?
Sensors can.
The sensors can tell you something, right? Okay, they can sense the stress level at different sections of the bridge. So even when you have to shut it down, yep, exactly.
If there's a broken lane.
Yep. Or severe wind condition that can also cause a bridge to vibrate and cause problems too. So with sensors now you can actually know, okay, we have to shut down the bridge because the stress due to the wind and the vibration is too much and the bridge is now not safe to operate
It can
anymore.
almost be automated too, so they can just have gates shut and just
Yep. Yep. So that's why computers are an enabling technology. It can go into just about anything in our daily life these days, and make fundamental changes to how we do things. And I think that is just amazing. How we can do stuff like that. How many people snowboard? Okay. Can you imagine how snowboards themselves can be computerized?
Yeah.
How?
Designing flex.
Speed, have it code itself, have it tell you trajectory.
Okay.
Change its
Changing the flexing.
It's pretty important.
Oh, really? Oh, interesting. Okay, go ahead.
Well, like professional snowboarders, if they put sensors onto their board, they could see what they were doing wrong by analyzing it on a computer.
Okay, so it will help in diagnosing, different type of techniques. Which technique works better. Yep.
You can make your board switch from camber to reverse camber, which camber is for going on like a really icy slope, and
Okay.
Reverse camber is more for going in the like deep powder. So I think we could switch it.
You can switch the two, and the sensor can tell you the condition, so it can kind of give you an alert. Yep. And you can also build in, GPS, like emergency beacon and stuff like that onto a snowboard itself, so people cannot forget to bring, the little GPS or the little beacon in case of, accidents or whatever. If people need to locate, you, then they know. Okay, the snowboard itself is emitting that signal. So that's how technology can get into just about anything.
Even in pens and stuff, they have pens that let you do stuff.
Yes, they have the.
They've had that for a long time.
Yep. What is the name of that pen? Pen that can do recording.
Yeah. It records your writing. and then
Professor
puts it
Anaya
into
has
text.
one of those. Professor Anaya, he's got one of those.
That's a
I
name.
can't think of the name of it right now.
Okay, now I have to find out.
I know Evernote has one.
It's a pen.
Yeah.
It actually has
That's neat.
what you're writing.
Makes sense.
LiveScribe, that's it.
Yeah.
LiveScribe. This is also, something that would not have been possible without computers. Okay, and what you can do with these things is just expanding too. When it first came out, all it could do is to digitize what you're writing and also do the recording at the same time. But now it can do even more. Okay, you can do a lot more than what it could do just before. Some of these are Wi-Fi enabled, so whatever you're writing, you can actually stream it to a server right now. Yep.
To display. To display. To a Wi-Fi
display?
enabled display.
It's stream it to a server, so you don't have
Oh,
to
I
store
see.
it on the pen itself. But theoretically, they can also hook it up to a projector, so that you can show what you're writing on a piece of paper onto an electronic device without a camera whatsoever. Yeah.
You need one of them.
I mean, and the price of these things, have been stabilized too. I mean, it's not like, it doesn't cost thousands of dollars and only spies of big countries can use, right? I mean, you can, if you watch, James Bond movies, okay, the gadgets, back in the 80s and the 70s, we have surpassed those gadgets already. Modern technology has surpassed, science fiction. What people think, oh, it'd be nice and cool to have this. Oh, we got that. You can buy for $20 from Walmart. Yeah, you can see James Bond, in the Walmart in the shop for something. What's your name, sir? Bond, James Bond. Really? And you're coming here to buy what? A LiveScribe digital pen.
It's cheaper here.
All right. Well, I just think the possibilities are really out there if people keep thinking how to apply the technology.
But there's always someone pushing the envelope, so it's just always gonna experience like that.
Well, it needs people to think with a bigger box. As I tell people, there's no one can think outside of a box. It's just a bigger box for certain people, but it needs a bigger box because especially for people like me, in the 40s, we tend to think in a certain way. This is how things are, and it will keep going in that direction. But it really takes a lot of people thinking in bigger, in a bigger box to say, hey, we can actually combine this and do something that was previously impossible.
Well, I mean, just like with the Lego thing, they give us one little thing, and YouTube, how many things people have figured out with them? Just all kinds of insane things. So there's always people that are always.
And now, we're
open source.
Yeah.
Yeah. Well, but these days we are even beyond that. We are actually beyond Legos because we have 3D printers.
Yeah.
Okay, now we have 3D printers. We are now beyond what we consider as, oh, this is the quick and easy way to prototype and build something. We can actually use 3D printers to print a lot of different things.
They're sending one up to space next year.
That would be interesting. Without gravity, they have to design it, in a certain way.
So it's like a toaster size.
Yeah. And they're getting affordable too. 3D printers are now getting more and more affordable and more reliable at the same time. Okay, so are there any questions about the pre and post condition assignment? Because I'm hoping that many of you have at least gotten started with this one. Okay, so what I'll do is I'll give you one example today so that you guys can hopefully use that to help you with your homework assignment. So what I'll do is I'm going to give you little pieces of what you need to do your homework assignment, and then you have to kind of figure out, how do I connect these pieces? Okay, so I'll give you something like this first. Okay, so we have x gets y, and then we'll have y gets z gets x, and then we'll have y gets w. Okay. So it looks a little bit like your homework assignment, the first one, but the sequence is different, and we have different variables in this case. Okay, so I'll give you a precondition that is kind of similar to what we had before, but it's not the same. So the precondition of line 1 in this case is y starts with a particular value, so y equals to some value that we will just call k. And w starts with a value that we call, I don't know, n. Okay, there we go. Okay. Now I want to derive the post conditions step by step. Okay, so how do we do that? Well, the first thing is we have to figure out the post condition of line 1. So we'll apply what we have learned in the previous class, and we'll say the right-hand side of line 1, f of x, is y. Y does not refer to x, so therefore the function is not reversible. Okay, so we'll say there is no inverse, and as a result of that, use the forget rule, or the forget operation. When you apply the forget operation, the post condition of line 1 is based on the precondition of line 1, but you have to throw away certain things that you know. In this case, what information about which variable do we have to throw away? About x, because that's the one that we are changing. Okay, so we'll throw away everything that we knew about x, but we also gain something. We also know that from now on, x and y are the same. Is that making any sense? After line 1 executes, x and y must be the same. So that means we're going to expand this. We'll say, oh, what is pre1? Well, pre1 is given to me. It is in this particular form. We're going to forget everything about x. And we also know that x and y will be the same. Now, we take a look at the precondition of line 1. And then we ask, does it mention anything about x?
No.
No? Okay, so we get to keep the whole thing. And on top of that, we also know x equals to y. Now, yep, go ahead.
When we're doing our homework, do you want to split the right side of line 1 f of x equals y? Like those 3 lines, you want to put that for every...
Yeah, you can just copy and paste it because you'll be using a word processor. So you can copy and paste if you want to, but I do want it there because I want you guys to, I want to emphasize, why are we using this particular operation? Yep. All right, so we are almost done here. We're going to push it one more step, okay? Now, if you look at this particular program, we know that x, y, z are the ones that are getting changed. On the other hand, k and n, are not modified in any way, okay? So let me ask you this question. If I just say, x equals k, and w equals n, and x equals y, and x equals k, is that consistent with the previous statement? In other words, this statement here and versus this statement here, are they the same? Are they equivalent? If one is true, is the other one also true?
Yes.
Yeah.
Yeah, they're equivalent, okay? But it is important, okay? It is important in this case, and I'll show you exactly why, because in your homework assignment, you will encounter a similar scenario. Okay, so now we move on to line 2. Okay, I'll just do exactly what I told you guys to do, copy and paste, and change the line number, right? The right-hand side of line 2 is f of z is x, and there's no inverse used to forget operation. The first thing you have to do is to say pre2 is post 1. That part is kind of obvious because lines 1 and 2 are sequential. Then we can now work on post 2. Okay, so post 2 is pre2, but we have to toss away everything that we knew about z, right? And after this, we know that z and x are exactly the same, and then we can now just work on the whole thing. So we say pre2 is post 1, which is this thing here. It's really long and kind of cumbersome, but we'll just copy and paste it. Okay. And did we know anything about z before? If we look at these 4 equalities, nothing says anything about z. Okay, so that means we don't have to toss away anything. We keep the entire thing, and then we also add on top of that, z equals x. Okay. Any questions? Now, since we already know what x is, it seems like we can also do something that seems to be rather redundant and say z also equals to k. Right? Because if x equals k and z equals x, it implies that z equals k. Okay, seems like we're doing.
Hasn't you done that in line 4 of post 1 y equals x?
Say again?
The 4th line of post 1, because we have y equal k and x equal k.
Yeah.
Could we have simplified that on the 5th line and say x equal y?
X equals y.
Because
We already have that.
Oh, okay, that's right.
Yep. That's okay. We are just adding something that seems to be redundant. Okay. But the redundancy will come to an end, soon. Okay. So now we are working on line 3. So we once again use the same reasoning to say that we have to apply the forget operation. So we just have to change these things a little bit. Okay. So this is line 3. There's no inverse used to forget operation. So now we say pre3 is post 2 because lines 2 and 3 are sequential. Okay, that part is pretty much the same thing. And now we try to work on post 3. Post 3 is the forget operation applied to pre3. And we have to forget everything that we knew about y in this case. Ooh, okay, so this time maybe we are going to forget something. Okay, so y equals to w. Okay, so now we will go ahead and I'm moving this up because it's at the bottom and some people may have a problem seeing it. All right, so now we expand what is pre3. Okay, pre3 is post 2, which is this seemingly kind of redundant big mess here. And we're going to forget everything that we knew about y. And on top of that, now we know y and w are the same. Okay, so now we look at this mess here, and we say, did we mention anything about y?
Yeah.
Oh, we did, okay? In fact, several times. This one is gone. This one is gone. And we only have that much left. Okay, now that we know z, oh, we have forgot one thing, y equals w. Now, because we also know that w equals n, we can also say that y equals to n. That really doesn't hurt anything. Okay, I'm going to add it in the next line. Sorry about that. Do this part first and separate that step to the next one. Okay. Are there any questions? Yep.
So since we're doing this in off this loop, right? So if we do the forget with it all plugged in, could we do strike through on it, like just to make it more clear? Like
Absolutely. Yep.
Okay.
If you want to use strike through, that's even better.
Okay.
Okay. So why did we go through all those steps and say, hey, we did not have to say anything earlier but they turn out to be useful. Why are they? Why is it useful? In other words, because of this and this, we know that x equals to k. Why is it important to state that y equals k in addition to y equals y? Because at a later point, we say, oh, we just changed y. So everything that we knew about y may not be true anymore. But if you decouple x from y by saying, oh, you know what, y equals to k, and x equals y, so x equals k now. X equals k by itself as a condition is now decoupled, which means it is now independent to the value of y. I can make the y value change all I want later on, and it won't affect this fact that x has a value of k. Are we doing okay so far? So what you need to do in your homework assignment is also to do something like this. Identify the names that do not get changed over time. Okay, you have two names that do not get changed over time. And what you want to do is to establish equality to those particular names as much as you can, after each derivation using the forget operation. So that way, when you update a variable later on, it won't affect things that should still be true, and you won't be erasing it. This is an example to illustrate it, because if all you have to do is to say, okay, but what if we did not state this this particular condition that seemed to be redundant? Okay, just go ahead and do it one time, but without adding the quote unquote redundant information, and you will see the end results will be quite different. Okay, it'll be quite different. So do it without this one, in the first step. Do it without this step in the second step, and then you will see, the post condition really doesn't have much to say. It cannot relate the variables back to n and k anymore, which is the bottom line of the homework assignment, because those constants are actually useful. Yep.
On the homework assignment itself, down at the bottom says something about put your answer here. What do you?
Okay, let me open it up and we can take a look. Okay.
Drive post. Show your work here.
Yep.
So we do we do it on that piece of paper or on that?
No, it's not a piece of paper. You just keep typing.
Okay.
Yep, you just keep typing, and then it will move the border, forward.
But I didn't know if you just wanted 07 on there, or if you want the whole thing.
No, the whole thing, the whole derivation,
like
the whole 9 yards. Yeah, basically what I just did, except you also need to take care of the conditional statement. Okay. You will see that by the time you get to the end of this, we will know something about x and y. They would have a particular relationship, at the end of the whole thing.
Can you go to the exercise just work on?
Say again?
Can you go to the exercise just work on?
The next one?
No, the exercise you just did.
Oh, okay, sure.
Scroll to the up again. The first statement you wrote y equal k and w equal n.
Mm-hmm.
Can we start with x equal k and y equal n? We have to start with this thing.
In this case, no, because this has nothing. This doesn't state anything about x as a precondition of line 1. You cannot add something that may conflict with what is actually given to you in the program.
But why you choose this method? Because y is not.
Y equals k. So I know something about y. I know something about w, but I don't know anything about x nor
Is this a part
z.
of the question?
Huh?
Is this a part of the
This is a part of the question. This is given to you, so you have to use it as a given, and then derive, post 1, post 2, and then post 3.
I just got it.
Yep. So in a way, it is similar to your homework assignment, except it's a little bit simpler. But I want to illustrate the importance of linking the variables to the ones that do not get changed over time. Okay. All right. So we are running out of time today. I'll see you guys next Tuesday. Have a nice weekend, and don't forget to do the homework. Sorry.
Can you sign this? Yeah.
Okay.
It's from Lisa.
Okay. How do you find Mason useful?
Yeah, very useful.
Okay, that's good to know.
Oh, wrong one. Right here. Yeah, there's a lot of tutors in there, so it's really helpful. And then Will made this really useful for trying to figure out scholarships and stuff.
Well, and also, most of the students in that setting have the similar goal, similar value. They
They
value
actually
sort of-
care about getting good grades.
Well, not just the grades, but actually getting the material.
Yeah.
Getting ready, for the next step and so on and so forth.
Yeah. Everybody in there actually gets
They
it.
actually need help with grammar and stuff. There's like somebody offended that has taken this class before.
There's
He will
lots
help
of
you.
them there, yeah.
No, but like I have asked around.
cisp300.
No, yeah, but they'll be like, oh, because they hadn't taken TAC.
Oh, gotcha.
But-
There's somebody that's actually taking tax.
Yeah, there's actually in there somebody that's taken TAC because I've asked around too. They'll be like, oh, I can help you with that one because TAC uses a different form from other professors.
What's that?
So,
I haven't started yet.
Well, after the first
that's why we can't cheat TAC. We can't cheat on the final.
What?
Huh? Because other professors use different kind of what's it called it?
Access.
They do their class assignments
Computer
different.
science, programming access,
Like how you do your coding thing?
computer information.
They say that other professors do it like way
I already
different.
did a major in
Which one?
network management.
The-
Part of that I took
Just this.
no,
Oh, what we were doing a second ago.